Guys, this is video 3.2 for Algebra 2. We've used tables and graphs for solving linear systems. Today we are going to be using the algebraic methods. That would be elimination and substitution. Let's start out with substitution. If you are given two linear equations and one of them is already solved down to what one variable would be, such as this one here is solved for y, substitution is a very easy method to be using. So what we're going to do is we're going to take the other equation and we are going to write it, but instead of writing our y, we're going to write what y is equal to. So I'm going to take my x, and instead of my y, I'm going to put in what substitute what y is equal to. So that would be x plus 2 equals my 8. So this is our second equation with our first equation substituted inside of it. From here, I'm just going to simplify, take my x's and add them. So that would be 2x plus 2 is equal to 8. Go ahead and subtract my 2 to the other side, giving me a 6. Divided by 2 gives me x equals 3. Now I need to find my y, so I'm going to substitute back into my original problem. So if y is equal to x plus 2 and x is 3, then y is equal to 3 plus 2, or y is equal to 5. So the solution for this linear system would be at the point 3, 5. When you write these, you need to write the point, your x and your y values together as a point, because that's what we are solving for, is what x and y are together in the equation to be a solution for this system. If they are not already by themselves, all you're going to need to do is manipulate them. Either one would be fine. I would solve for my y in either equation because the y is already mostly alone. All you need to do is take one of your variables to the other side. So I'm going to work it both ways to show you that we're going to come up to the same answer. So on this side, I'm going to solve for my first equation and get my y alone. So that would be y is equal to 6 minus 2x. I'm going to substitute that in place of my y. I would have a 6 minus 2x minus 8x equals 1. The reason I always put it into parentheses is just to make sure, just in case there's a negative that needs to adjust all of the signs inside the parentheses, just to be on the safe side to make sure that my signs all come out correctly. Or that if there's any multiplication that needs to happen in distribution, that happens the correct way. All right, so my parentheses isn't going to change anything, so I'm going to go ahead and drop it. So 6 minus 2x minus 8x equals 1. I'll have 6 minus 10x is equal to 1. I move my 6 over, giving me negative 10x is equal to negative 5. When I divide by negative 10, I'll have x equals 1/2. When I substitute that back in, I like to substitute it into an original equation, not one of my adjusted ones. So I'm going to go to my 2, and instead of x, I'm going to put 1/2 plus y equals 6. 2 times 1/2 is 1 plus y equals 6. And then I subtract my 1 to the other side, giving me y equals 5. So my point is 1/2 5. So let's solve for y on the other equation and show you that it's the same thing. So I'm going to take my 8x and move it to the other side. So y is equal to 1 plus 8x. When I substitute that in, I will have a 2x plus 1 plus 8x equals 6. You can see here, if that was a negative sign, I would have to change all my signs on the inside. Since it's a positive, I can just drop my parentheses, giving me a 2x plus 1 plus 8x is equal to 6, which is a 10x is equal to 5, and x is equal to 1/2. When I plug that back in, let's plug it into this equation this time. We have y minus 8 times 1/2 equals 1. Negative 8 times 1/2 is going to give us negative 4. So that is y minus 4 is equal to 1. When I add my 4 to the other side, I will get y equals 5. So my point once again is 1/2 5. So it doesn't matter which one you solve for, which one you plug it back into, you're going to get the same answer. Elimination is the other way. If your linear equations are pretty complicated, it wouldn't be easy or neat to have a variable all alone. Elimination can be a really good method for doing this. What's important is that you pick one variable that you're going to eliminate. When you do, think of it as how do you get rid of a 10? You subtract the 10. So they have to be the same number and they are opposite signs. That will give you a 0. That eliminates your variable. So this one's already set up nicely for us. We have a +3 and a -3. When we add these two lines together, our y's are going to end up with a 0y, which makes them disappear. So that's what we're doing when we're doing elimination. We want to get one variable where the numbers are the same and the signs are opposite in order to eliminate them. So all this is, I'm going to rewrite this over here. This is an addition problem with two different, it's important to write the right problem, 34, not 38. It's an addition problem with letters. Okay, so when I add these up, I will have a 2x plus 4x is 6x. My 3y minus 3y makes my y's disappear. 34 minus 4 is 30. I'm going to divide by 6. So x is equal to 5. I'm going to substitute that 5 back into either equation. It doesn't matter which one. So let's do the 2 times 5 plus 3y equals 34. That would be a 10 plus 3y is equal to 34. Move my 10 across, giving me y is equal to 24. Divide by 3, so y is equal to 8. So my point is 5/8. First thing that I look at right here, neither of these are already solved for a y. Besides the instructions tell me that I need to solve by elimination. But also, neither of them have the same number and different signs. A lot of yours are going to be like this. So you've got to decide which one you want to get rid of, and then you've got to multiply the whole equation by the same number in order to get them there. So let's say we want to get rid of our x's. So what is the greatest common factor that they have in common? Or no, not greatest common factor, like the least common denominator, or only we're looking for the least common multiple. Okay, so my 2, it would be a 2, 4, 6, 8, 10. What's the closest one that I can take my 3 to? Well, it's not the 2 and it's not the 4, but it is the 6. So what do I need to multiply both of these by to get them to be a 6? So I'm going to multiply the top one by a 3, and I'm going to multiply everything in the top by 3. And then I'm going to multiply the bottom one by not just a 2, but I'm going to multiply it all by a -2, because that will give me a +6 on top and a -6 on bottom, allowing my x's to eliminate. So let me rewrite that. I have 3 times 2x is going to give me a 6x. I have my 3 times my 4y, which gives me a plus 12y. And I have my 3 times my -10, giving me -30. Now I multiply the bottom by a -2. So -2 times 3x gives me -6x. -2 times 3y gives me a -6y. Put plus. -6y. -2 times -3 gives me 6. And now I can add them up. My 6x minus 6x cancels, leaves me with 0. 12y minus 6y leaves me 6y. -30 plus 6 gives me -24. Now when I divide by 6, I will have y equals -4. I'm going to plug that back in anywhere. Let's do it in the bottom one this time. So let's do 3x plus 3 times -4 equals -3. So I'll do my 3x plus 3 times -4 is -12 equals -3. I'll have 3x is equal to, when I add my 12 to the other side, it will be equal to 9. And so my x will be equal to 3. So the solution here is 3, -4. Sometimes when you work on your systems here, you're going to come up with some interesting classifications, some interesting things are going to happen. All right, so let's look at this first one. I'm going to solve for my y because my y is all alone, and then I'll substitute. The other way you could do it is you could multiply your top here by a -3, right? Let's just do our substitution though. So I'm going to do y is equal to 8 minus 2x and plug that in place of my y right here. So I'll do my 6x plus 3 times 8 minus 2x equals -15. Now I'm going to distribute. So I'll do my 6x plus 24 minus 6x equals -15. My 6x and my 6x are going to cancel, leaving me 24 is equal to -15. Is that a true statement? It is not. So we would say that this is no solution. There is nowhere where these two lines are going to cross. And that'll be it for today. Now, if we had substituted in there and we had found that we lost our x's and we ended up with a true statement like 0 equals 0, then we would say that it is all real numbers and it is infinite number of solutions because the lines coincide and they are the same line. So have a good evening and I will see you later.